Good morning, Namaskar. This is Yasu Singh speaking from Bharat, India on this day, October 20, 2021, Wednesday. Quality. Just a look, please. साढ़े तीन. Okay, dear friends, I tried to show you some glimpses of what I intend to do or what is intended to be done on quality front, safety front. Usually, I talk but try that you should read yourself certain papers and pages. And that's actually very important from each and every point of view. We are talking about we are talking about systems. We are talking about quality. We're talking about safety. It's a miscellaneous kind of routine talk and title, every day we discuss, and it is civil, field engineering, life related to that, engineers, what they are, quality, what does it mean, and what to do with that, and what is AnnexSL, that is high level structured language related to quality system. Then what is red and silver form formats, what is safety, health and environment, what are designs. Then this is one part, while direct work on sites, that is construction, methods, contracts, organizations, communication, coordination, and why always be behind quality of works, quality of materials, and quality of whatever is involved in system. It is easy to speak, and I am speaking. Everyone can speak, everyone can write, we can think and we can do whatever comes to mind in logical way. What is intended to be done is something different. We have to streamline our way. Streamlining something to defined requirement or a specified requirement is very significant in a way that process goes on and on. When I say streamline, this means a kind of different type of method where no doubt remains for achievement. When no doubt remains, we can say that's the only way we can accept or we can reject. It is sometimes we say engineers are problem solvers. We say that, and it is fact also. Engineers are developers. Yes, they are. Engineers are agents of change. It is very significant that engineers are agents of change. Every change. Engineer can convert a forest or a desert to a city or an industrial town, for which quality and safety, health and environment play integrated and merged vital roles in all respects. We know that. We know also we know also engineering means quality application and continuous improvement of quality. No way exists not to comply with defined or specified quality levels, because definition of quality is a must, and that definition requires to be achieved. Now, important point is non-conformance. Non-conformance. Why it happens? Why does it happens when we are there technology exists, experts exist, workers who are trained, they exist, morale exists, working capacity exists, time exists, material exists, cost exists, machines exist. When every requirement exists, what is reason? What we can say is real reason. What is real problem? You can say that we say non-conformance on every project, on every work. Non-conformance is seen. Of course, not you can say 100%, but on major works, non-conformance is witnessed, is evidenced. And if it happens, question arises, why? When engineer is there, why engineer does allow such non-conformance to happen? Its answer can be very simple. It can be that no engineer is interested to do that. Even then it happens. We can simply say either mental eyes are closed. I cannot say about physical eyes. Mental eyes are closed, or something is not given due care. When something is not given due care, there can be expected deviation from indicated or specified direction or route. You may say we sometimes miss something which should not be missed. It happens. Or sometimes something goes to hands of those who are not very seriously competent. They are incompetent. I cannot say those persons, those employees may be bad. There could be certain circumstances which could force them to ignore. This is very important part to discuss. Now we talk about engineering. We talk about designs, we talk about prosecution works, and we talk about applications when they are effective, and that's called engineering. And we can say quality non-conformance product is called substandard and therefore rejected. Yes, that's right. If we reject non-conforming product every time, just like we command in management world, you do every time, whatever you do it right. Means do right every time. Do right every time. This means do quality work every time. You do first time every time right work. You have to do right work first time every time. It is clear understanding from, you can say, organizational viewpoint or work viewpoint. Just like we say safety first. Yes, first everybody remains safe, must remain safe. Every time is first time. When you do something, do safe. Do not do unsafe. We can say nobody is safe if they are unsafe or they are ignorant. Focus must be given to safety and health. That is for personal. That is for human resource. That is for equipment. Same way, safety must be given to standards of work and standards of materials involved in work. We have to understand this point. Ignorance is not accepted in work. Closed eyes are not accepted in works. Negligence is not accepted in words. When we say engineering, engineering means work according to system and work according to quality requirement work according to what has been defined for such work, for such process, for such construction. And engineering means it should be right work, it should not be bad work. Bad engineering is not accepted, only work is accepted that complies with requirements. We have to think on everything, we have to achieve every requirement, and that is called power of achievement. Power that we have got, or we can say competency that we have got, and we are consistent and competent in our working approach. There are so many times we discuss that. Analysis for everything we have to do, and it's a part of analysis also that is being contemplated about. Analysis is a mathematical word where not necessary that you use differential equation or Fourier equation or whatever else. You have to use mind for solving problem, and analysis is that process. You have to solve certain problem, that problem you have been given with. If you are not able to understand problem, if you are not able to understand problem, there may be many issues involved with that problem. Those issued those issues are required to be solved. If we cannot solve those issues, we cannot solve anything. This point we have to understand. We have to understand them explicitly clear. That analysis is that part of engineering on which engineering is based. Engineering is founded. This is an entirety of process. Analysis cannot be replaced by something which is not clear. We cannot say, do it because I have said or I instruct you. You can instruct someone if you are clear about that, if that is accepted engineering term, or that's accepted engineering formula, or you cannot instruct someone based on because your intuition says or because you like this. That is what engineering is. Use of mind and authorized use of mind, and you can say applicable use of mind, and mind that gives, that delivers such process, some construction through some delivery which is based on certain analytical and synthetic way. We have to apply analytical approach to each and every issue in engineering, because analysis is root of requirement. What does analysis say? It says in each and every member, wherever we work, in each and every member of that structure, each and every part of whatever part you manufacture, analysis applies. It gives you force or it gives you something else. This is a requirement, you have to fulfill this if you want to use this product, if you want to use this body. It's like that. So you can say, if we do not understand analysis, we cannot understand structure, we cannot understand life. Every family has problems, every individual has problems, every every problem requires be studied thoroughly by conducted a process of analysis. That's why we say in engineering analysis is very significant, and in non-engineering world also analysis is significant, very significant. It's not necessary that I'm talking of engineering only. I'm talking of life engineering here too. It may be not in that definition, but after all, it is engineering. We have to realize this fact. So I say we talk of contracting, I say we talk of EPC contracting, which is for construction, and before construction, that is for design also. So we can say design plus engineering, I'm sorry, design plus construction equal to total project. means you are responsible for designs, and this means you are responsible for scope requirement. You are responsible for performance of your work. You are responsible for all aftermaths or you deliver something. Means you cannot just blindly do. You have to design first and then you have to execute that design, and this is equivalent to called EPC contracting, because EPC is a medium of contract used for such projects. It's not something irrelevant. Means honor has given you something to design it to meet project requirement and then to construct it to meet design requirements. This means it's related to social cause, it's related to national cause as well as international cause, because we are talking of certain considerably sized mega project where every resource, whatever is included, amounts to quantum, high level of quantum. This means it affects professionalism, it affects life, it affects engineering, it affects quality and safety, it affects designs. Then it is done through construction, it's done through manufacturing, it's done to industries activities, and of course there may be some methods that are required for each work. Contracts, of course, are intended, contracts are dealt with, and we can say, of course, track of all this movement, track of all this progression, that can be called communication and coordination. We have to take this point into mind. When I say analysis is such a term that applies everywhere. This means if I get a contract for doing EPC work, this means I have to analyze first everything before offering something to some owner or some client. Means I have to know, I have to understand total requirement of that employer or that party, owner. After only that, I can say I have due capacity to design and construct. Design and construction. Designs and construction are not very difficult, but not what is required for. What is required for? We can say we can do that. We cannot do that elementary wise. We can do that relative wise, relation wise. We should have basic information first. If we don't have that information, we cannot even think to design. Whatever information from engineering viewpoint and whatever information from non-engineering viewpoint, we should have all those information ready, or we should have separate record for those requirements. So it's very significant to consider that the terminology we are using here is analysis, professional analysis, which is, you can say, some path to that sometimes pulls you back and immerse you in its knowledge to upgrade yourself. Technology never stops. We have to understand that. It keeps on moving and moving and moving. And that is beauty of technology. So what actually we say? As owner, as EPC contractor, everybody has to think for itself first. Owner or employer or company, EPC, is responsible for doing its job, and based on allocated budget, allocated requirement, works move on. That fact we have to realize. It is not just too easy. It's not a small room or hut. It's facility plant. It's major part of construction also. When we consider facility plans, it's very significant that such designs cannot be done at once, even if we have engineering staff, until we have complete information from intermediary sources, from vendors, or from some other data given to us. We cannot conduct any analysis. EPC contract where responsibility goes to contractor and relative responsibility goes to engineer or we can say honest representative. In fact, when I say honest representative, I have to deal with engineering part of that, engineering part of that, quality part of that, safety part of that, and whatever regime is involved. We have to think of that, we have to analyze that, we have to decide something. It's not easy to decide about some contract related works or to decide about what is the requirement of area, because such requirements are large, are considerable, are powerful, and these affect social change. We have to understand that. Industrialization is very important for every country, and it's very expensive also because all inputs are required. So we talk about EPC, which is full formed as engineering construction, engineering project. You can say engineering project construction. This engineering is involved. You can say procurement is involved, construction involved. Is called EPC, where you are a designer, you are a buyer, you are a promoter, and you can say I have to deal with project. You can say you have to deal with construction of that, with commerce of that. EPC is a complete world, and I cannot say being EPC you have to deal with this, but whatever work you do, whatever material you buy, you as UPC, EPC, even you can say a car you buy, scooter you buy, it's also kind of EPC, though it's not EPC in terminology, but function is same. That purpose, that person who delivers something, that is designed by that person, manufactured by that person, the responsibility is taken by that person in terms of limited warranty or limited guarantee. Same way here, who is responsible for your health? No one else but you. I am responsible for my health. These points we have to be very clear about while you talk why. I wanted to share with you very much responsibility on EPC because EP is very common terminology, and every company, every organization that deals with EPC must be a very high profile organization because it has to take care of designs as well, not only construction but also designs. And when you talk of designs, you should have very high profile people with you, high profile key personnel. And when a professor of honor, or you can say a limited head of the organization, knows very well how to receive these people. Public feels happy when there's development, but public also feel unhappy when development doesn't work. When development doesn't work, it doesn't work because there have been some shortcoming either in designs or in construction. There are rare chances, seldom you can say designs are challengeable because designs are based on practical as well as theoretical input. Those designers who have experience, they can use their experience also to be included or to enrich design. So design is one part. Design is one part of EPC because without designs you cannot do anything. And design means contemplation, design means thinking, design means dreaming. Design means whatever you are dreaming, whatever you dream of time design, that should be totally focused on requirements, and requirement must be in writing. What do you want? And that requirement is basics one, minimum one, and what you can do more than that. You have to consider this point very seriously. For me, EPC is better. For someone, construction is better. For someone, industry work is better. For someone, shop is better. For someone, this is better and that is better. But what is better? Whatever I have been given, whatever I am doing, I will do by use of heart, by use of eyes, by use of stamina. I think it works. So we say policy decision, authorization, technology promotion. So that's what we have to do. Every government has to do. It's nothing new. It's not something extraordinary to do. It's job. We have to decide. We have to decide, and it's not for one country. It's for all countries. So we can say we had gone to certain justifications, and we may start we're talking of certain facilities yesterday. Facility justification, etc. we have done. I talked of that. What is justification? What is this? What is that? You are somewhere on components. Maybe I am jumping high. Let us say, what is that? Certain inclusions are here. It says facility justification, and we see this one here too. Facility requirement. Of course, it is let's say policy decision. Before that, it is space scope backing. Scope backing. Let's say this versus it is necessary in interest of economical development that an industrial project should be efficiently promoted for industry being backbone of a nation. That's true. Which keeps nation moving forward, improving quality of life of its subjects. Sooner is industry created, better would be prospects for economy and nation. Therefore, value engineering should efficiently be applied to products, goods proposed to be facilitated, to enable consumer be delivered with avail most economic and quality products. When we talk of industrial development, we target to achieve a potential industry. We achieve potential industries for long-term production of intended products that may cost in billions. Its concept from front-end design feed execution was certainly quantified to considerable quality, cost, and time in every respect. All types of major industries require development in line to meet public or economic requirement of nation or of internations. Which class of industry should be promoted for modernization depends on various relevant criteria as well as development of engineering. We have discussed all this before. Now, back to discuss about, we were talking of policy decision, authorization, they can involve governments should promptly work out policies in positive or constructive or development manner. For time is extremely significant factor which can be used properly to get optimum use of project provided adequate funds are available within allocation of budget or institutional financial borrowing should be made. Value engineering as we discussed before, should be properly studied by experts to reach a conclusion. The proposed product shall be processed, imparting no adverse impact on existing environment, shall be most economical in production, cost, be easy to be transported to consumer market, be most beneficial to national society from every aspect, view cost and economy uplift as well as promote use of given technology and provide benefits to all people located globally in long run. A right and reliable charter must be constituted at every initial stage of conception for a permanent reference, including various information such as aim, target, policy, political impacts on area and nation or society, rehabilitation and other bad effects requirements of additional infrastructure, generation of employment opportunities in both stages of promotion of project as well as its operation, and can say we have to achieve value engineering. In fact, maintenance technology, stakeholders, current value, earned value, long run value, continuous benefits, expected risks of all sorts, whether or not other alternative products could be promoted, achieve better value engineering. And sustainable development. Sustainable development means a state of an art technology on projects which technology does not go against can say existing requirements, or and neither now these are all concepts. Value engineering work, it says value engineering plays a significant role to many extents. There could be options and options, all these are there. Now, what is saying facility requirement? Let's have a brief look on this. Value engineering based effective application, effective technology, product and user requirement. Value engineering based effective application, effective technology, product and user requirement, necessity, approval and financing, international computation, cost effectiveness, safety, health and environment, tenability, sustainability. Should these points be met by social, economic reasons, you can say, should these points be made proposal, project may be given a go ahead. Only value engineering factor has been included into plan considering with full integrity in the cooperation of provisions in line with national and international policy for such evolution and development. Once value engineering factor has been included in plan consideration with full integrity of incorporation of provisions in line with national and international policy for such evolutionary developments, there means no meaning to delay a project's initiation by charter authorization by respective stakeholders should be done. Finances, of course, have to be allocated to statutory requirements to give you go-ahead, various phases, stages of project development, so as delivery be made in defined time for follow-up. Operations for consumer and users. Since facilities demand incorporation of inputs from various disciplines and personal, material, and equipment with licensed technology, every criteria must be kept in consideration for a final startup. Facility justification feasibility, environmental sustainability, environmental sustainability, environmental sustainability, cost viability in long term, nationally beneficially, nationally beneficial to add to economic growth, multi-purpose approach, and creation of employment, casual as well as schedule. So we can say otherwise export potential of product. Export potential of product. Processing technology and availability of raw or natural resources. Processing technology and availability of raw or natural resources, materials, adequacy of availability of terrain and routes, selection of planning and execution mode, availability of expertise and experts along with all other interrelated professionals, availability of all human and all other resources, their original sources, international agreements for bilateral trades with production, producing nation, finalization of design rights, copyright processes, technology license, agreement on various contract forms, adoption agreements on international workforce migration for projects, public-private partnership and government responsibility, international joint venture. Say availability of relevant trade zones based on subsidy for industrial promotion in general public interest for long-term construction and operation, certainty of return by reliable process after a defined set of years or an assessed duration after which the investment is made and the asset for remaining life of plant facility. Components elements of certain processing facilities. We say inclusions in general, let's say it's just for purpose of understanding. I'm just trying to share my experience based projects here. It's not that this should be mandatory for everybody, just for purpose of explanation, purpose of extending or providing input, so that you may also think in that way. And said, what may be included on projects could be elements of certain processing facilities. These are neither permanent nor integral, but how can something be, you can say, applied without having basis of JS? Availability of natural gas example is there in oil fields where natural resources are being tapped out from offshore location of various seabed founded rigging platforms, allowing risers lead pipes to upstream onshore slug tanks. Ability of Availability of all well-equipped facilities of shipment, platforms, injections, and risers for raw or delivery of everything. You can say all equipped facilities of shipment, platforms, injections, and risers for raw oil delivery from seabed. Ability of land for required downstream processing area on shore with unacceptable terrain that may be used for operating complex the chemical process. Then we can say availability of all well-equipped facilities of a shipment in platforms, injections and risers for new oil delivery from seabed. Availability of land for required downstream processing area onshore with acceptable terrain that may be used for operating complex chemical process engineering applications use on well designed trains as well as transportation of proceeds, processed products and byproducts to specifically located outlets, leading byproducts to specifically located outlets leading to consumers locations. Plant processing scheme and technology both for green as well as brownfield, supported with authorization by legal license valid for defined period. Liquefied natural gas LNG, wait a minute, plant processing scheme and technology both for greenfield and brownfield, supported with authorization by legal license valid for defined period. Liquefied natural gas LNG tanks made of cryogenic steel RCC pre-stressed concrete containments with spillage and other components etc. for storage purpose at considerable minus temperature. Plant processing trains elements plants processing trains elements complete with detailed descriptions of heavy and light industrial equipment, utilities, areas, elements for integration with plant equipment, offsite, offsite, offsite elements for subsistence to aforesaid provisions, aforesaid inclusions, intake piping system arrangement for circulation and delivery into plant equipment for cooling process or application. Seawater basin for storage of seawater to be used for cooling purpose during various processes, delivery of cooling water to plant and then recirculation for further cycles of processes. Pipe supports pipe sleepers, pipe racks, or product transportation, and relevant handling operational activities, service air and instrument air circulation piping, chlorination plant with complete systems, package for purpose of chlorination, water for supplies to plant use, storage and warehousing for physical handlings of subsidiaries, drainage infrastructure from plant to receiving basin, and then to outfall structure to discharge channels duly provided with metal lucks and channels. Ditches ditches completely lined to convey out to final discharge stormwater from various catchments area of plants. Complete package drainage system for oily water, acid water, dusty water, sewage, etc. that comprises of hundreds RCC manholes, many hundreds RCC manholes, many kilometers of pipelines, connection with such manholes and chambers, leading and disposing to sewage treatment plants, STP. What line for whole site? What line for whole site? For various purposes, you can say, including loss prevention, that is fire suppression before it happens. Firefighting requires to be avoided if loss prevention is done. Fire suppression, firefighting with fresh water as well as with backup seawater supply from seawater reservoir or elsewhere. Cooling water line provision throughout whole industrial zone, taking in water from intake at sea, supplying to industries, and then through return headers discharging it to sea directly after being supplied once as well as employing cooling water system. Technology to recirculate used water and only make up water to be supplied. Pipe supports, pipe sleeve, pipe encores, channel encores, big encores, thus blocks placed in various defined spacings. Pipe supports to be connected to sleepers. Pipe supports to be connected to sleepers and direct supports using structural steel connections for both direct clamping as well as achieving sliding action to make up for expansion, which supports are often considerably heavy units for considerable size pipe. Electrical heat tracing provision for piping system carrying minus temperature, liquid or gas to keep maintain pipe on required temperature so as to not to allow freezing of material. For example, sulfur gas can freeze within pipeline. Heat tracing works repeatedly encompassing pipes, transferring thermal energy to pipe and then to internal available gas at minus temperature so that the gas does not freeze in pipe but keeps on flowing at specified temperature and velocity. Known blast buildings. Known blast buildings such as administration as well as amenities buildings elements for facilitating operational maintenance as well as consumer supply. A sit station that should contain various offices with access control. Electrical main substation, substations, switch gears, package substations, pump houses, guard houses, visitors arrest, visitors areas, main units, visitors areas, ring main unit, transformers, heavy duty armored cables, centralized control to all such supporting on site or off site buildings for electrical distribution system and security system. Blast buildings such as central control as well as operations building. Blast buildings such as central control as well as operations building. In control whole plant operations from one single location, monitoring all engineering disciplines, plant surveillance 24 hours 7 days a week. Consumer receipt stations to be used by consumer delivery control located in gatehouse. We have consumer receipt station to be used by consumer delivery control located at gatehouse and intake pump houses and other processing pump houses of various locations duly integrated for controls or plant facility all over plant facility. And we can say water retaining. Water retaining structures just below ground sumps, receiving basins, drainage channel, outfall discharge to sea, site security arrangements, fencing surveillance by installation of CCTV, which with state-of-art technology. Site security arrangement, fencing, surveillance by installation of CCTV with state-of-art technology. Site telecommunications of all sorts. Site telecommunication of all sorts for effective, efficient use by operating personnel available in all security zones spread over entire facility. All loss prevention arrangements including internal and external firefighting. All arrangements to cater for fire emergency, blast emergency, on seismic emergency. Fire tender station is significant to cater for this. Then we have adequacy of plant and non-plant area, adequacy of plant and non-plant area of roads and paving, of roads and pavings, you can say adequacy of plant and non-plant area of roads and pavings, maintenance tracks, road crossings, utility crossings, road culverts, pipes, culverts, transit manholes, controlled defensive traffic movement and circulation, etc. Soil erosion protection for all machines and equipment, so that all these equipment should not get damaged due to possible negative impact by heavy dust laden storms. Facility by product plants association and all required elements for that. All related civil engineering disciplinary structures for buildings, sheds, equipment, vessels, as well as other processing and non-processing equipment. Vessels such as cracking furnace, wash water structures, crack gas compressors, propane compressor, ethane compressor, boilers, auxiliary boilers, various types of spheres, steel tanks, fuel towers, rotary equipment, reciprocating equipment, etc. shall be made part of plant with necessary foundations for these elements or components to be constructed on line. Construction line according to defined requirements. Massive concrete blocks shall be required for many such major foundations to found for heavy vessels. Civil massive concrete blocks shall be required for many such major foundations to found on heavy vessels. Civil engineering foundations structural requirement vary from simple machine plinth Civil engineering foundations structural requirement vary from a simple machine plinth to independent footings, to combined footings, to stiff footings, to raft and piles, as well as massive block foundation. Concrete shall generally be low heat producing cement paste manufactured by using microsilica or GGBS ground granulated blast furnace. Ground granulated blast furnace slag replacement cement up to 70%, replacing cement with 70% extent, and also pulverized fly ash PFA treatment for replacement. Now, says raft and piles is only to the extent and also provides fly ash. A PFA cement replacement. Supporting base of pipe rack may be allowed either by steel structure or RCC construction. Foundations of pipe racks. Foundations of pipe racks shall generally be of RCC basis, independent footings. Overhead crossing shall be required at many locations for various en-route piping to jump over existing plant circulation roads. Such overhead crossings could be constructed using structural steel. Cathodic protection, both critical and non-critical, requirement for centralized corrosion control of plant reinforcement from a central control sacrificial mode. Central control sacrificial mode. Station and station also be provided for long run, long term corrosion monitoring and corrosion controls respecting reinforcing bars. Earthing provisions for all individual structures, equipment as well as network. Colors are there: green, red, covered cable, trenches, RCC vault, buried directly to ground, or cable ducts shall also be used for these ducts shall be coordinated. You can say colored green, red, covered cable, trenches, RC vault, buried direct to the ground. Cable ducts shall also be included in design, forming a major part of some facility. These ducts shall be coordinated to various interface crossings, requiring site solutions to protect blind, supporting serious services, interface clashes. Heavy duty concrete pavement be provided in all points, all plant areas for required purpose of its maintenance, respecting machines as well as movement of heavy vehicles. On other areas, where no pavement is included, stone aggregate shall be spread and compacted to avoid soil adverse impact effects. On other areas where no pavement is included, stone aggregate shall be spread and compacted to avoid soil adverse effect on all vessel or equipment. In addition, all important administration areas shall be allowed an attractive soft and hard landscape architectural provisions. Access security arrangement shall also be made with automatic controls using card readers or fingerprints scanning, and also Now, access access security arrangements should also be made with automatic controls using card readers, fingerprints, scanning, etc., installing of CCTV for continuous control and records. Inclusion of flare towers and radio masts is also contemplated. Process areas means areas within which chemical trains work to run defined technology to work over adopted process. Non-process areas are those which are outside limits of process areas and support process areas. Non-process areas are those which are located outside limits of process areas and support always process areas. Administration area is that area where is that location where are accommodated buildings and required facilities to meet plant's demands for administrative and maintenance support. Administrative area may comprise of administration buildings or amenities buildings, warehouse, station, store, fire station. All structures of whatsoever material are designated blast resistant buildings, which are located within process areas. All structures of whatever materials are designated blast resistant buildings, which are located in 200 meters range from process areas. All other structures of whatever materials are located away from 200 meters process area to within 600-meter range are designated non-blast structures. Now I will go into the components brief on LNG tanks. LNG tanks. Maybe might have seen those LNG tanks I showed to you in that photo previously, which are not as visual as we can see, is not as we thought. Carrier projects involved, just a minute please. Let me see if I can find something out of that. Better if you can see something in carrier projects involved. I tried to show you other day glimpses of that, sometimes important. You can see that one. Carrier projects involved. Let's see, I can show you something in there. Let me see if I can show you something in there. Maybe I have that one, I don't know. This LNG tank here, all these are tanks. You can see. Uh, this is also here one. You can say SL one. This one. I'm talking about this one here. 3 tanks here. If you see closely, you'll find. If you see skies, this is. There's a tank here. This is a cupola of tank at top. You see, this is verticality here. This is surrounding, and this is top of dome, top of cupola. You find some operating platform, and then these are connected somewhere here because gas comes to these tanks for storage purpose, and then delivery sector is made. And there are certain tanks here, for example this tank here, sprays tanks are connected sprays, they are the sticks care of that. Now we're talking here is you see these components are meant to store liquefied natural gas, say 80,000 cubic meter capacity each within cryogenic steel. This capacity goes to here. Each tank has this capacity. Approximately you can say 80 meter diameter and 50 meter height up to start of couple level up to we can say starting, yes. So here we may say these components are meant to store liquefied natural gas, say 80 cubic meter capacity, 80,000 cubic meter capacity each with cryogenic steel tank. Cryogenic means which can digest minus temperatures. Every gas's condensed form is minus temperature. That's why tank is required there, cryogenic tank, because that's only material which can digest heat of winter. We can say it RCC with pre-stress arrangement of cables. Structure of cables is pre-stress arrangement of cables means cable tendons. Structure for 80 meter diameter, 800 mm thick wall, as well as provided with the height of say 50 meters. Height 50 meter is included for LNG spillage prevention. Each tank base was allowed soil improvement below ground by many meters, including many meters depth of granular engineered fill and layers thickness of fills not exceeding 200 mm each. RCC rod foundation was laid on imported fill. Pre-engineered formation after ensuring achievement of required design safe bearing capacity. Pre-engineered formation after ensuring achievement of required design safe bearing capacity. Top of tank was covered. Top of tank was covered with a permanent formed cupola structure. We have seen that. This is again I show you. This is cupola structure. This is cupola structure. Cupola here. This is vertical. You can see here. Vertical surface is this. And here is what I say. Okay. Top tank was covered with permanent formed cupola structure raised to its level by using compressed air pressure lifting. Compressed air pressure lifting. Cryogenic steel was included for construction of LNG tank. Cryogenic steel was included for construction of LNG tank to maintain about minus 60 degrees Celsius temperature of condensed gas. So we can say minus 60 degrees temperature of available gas. It's too low, minus 60s. Now concrete of circular walls was poured using quick form proprietary custom designed formwork in 5-meter lifts each. A cantilever operational platform was constructed on cupola edge. A cantilever operational platform was constructed on cupola edge as protrusion horizontally. An on-site designed plumbing system was erected temporarily for carrying out concrete curing activity throughout on full height of tank to cover all vertical areas for curing. Each LNG tank was provided with a RCC spillage below ground tank externally. Compressors foundations. Now, LNG, I'll take off. There's no meaning with this. I'll explain this one now. Let's now go to see if I can do something else. Talking of something here, let's yes, here are foundations. May say that. For example, I say this you can say possibly are compressor foundations. The wash water structures now these are foundations types here. May say that compressors. These are gas compressors actually, not air compressors. These are gas compressors. Compressors are to be installed. Compressors are to be installed as a part of various processing trains. Various processing trains for ethylene product unit. For ethylene production unit. Being heavy reciprocating machines to be installed on massive foundations at elevated levels. Tabletops would be constructed resting on massive concrete foundations. Do you know what I'm talking of? We're talking of this, right? It's very important one. We're talking of something very specific, and we can show. Let me close this first of all, because purpose of this is not major left now. Or let me go to see, explain to you directly something which is, I'll get something out of this again and see what we can show you. That's important, and you can say, I'm just trying to get you something very important here. Compressor found this tabletop, I'm not sure anyway. Let's see, because tabletop. Substation transfer tabletop to commercial office level. Start, head of reader, tabletop sketch, tabletop photo. I will show you photo. I think that's better if I show you that one. I'm showing this photo here. That's important. You can see this is actually big columns, thick columns, and below there, because below this is foundation, massive block, and these are thick columns, and this is slab of this column, and this is structure of tabletop. Just giving you show. We can show you its sketch also. Tabletop sketches here, and likewise you can see it's a sketch of this tabletop here. Likewise, this is your tabletop. This is columns, and this is foundation here. You can say this is foundation here. So that's what it is. I can say tabletop photos. So this is your photo, the tabletop sketch here. And also tabletop. Also, that's I think is photo here. Nothing else to do with that. Recognize that one, and there you can say. So you got it. You can say what I mean to say. You got it. I put it off also, so that it doesn't come in way off. Just tab. Also take it off from this one. Just tab. So I say foundation concrete for one cracking gas compressor. One please. See, compressors are to be installed as part of various processing trains for ethylene production unit. Being heavy reciprocating machines to be installed. On massive foundations at elevated levels. Tabletops will be constructed resting on massive concrete foundations. Foundation concrete for one cracking unit cracking S. Compressor being say 500 cubic meter. I would say 25 meter long, 10 meter wide, and 2 meters say B. Well designed machine foundation for a reciprocating vibrating equipment. This foundation carries thick columns, thick members, means sectional size more than 0.8 meter, and RCC quantity greater than 8 cubic meter. About to support tabletop. Steel plate built inserts. Between equipment and epoxy graft. Tabletops are constructed of thick frame slabs resting on thick columns. planned arrangements of tabletop slabs are complicated in all respects regarding civil as well as mechanical inserts. Such types of thick and massive elements require special type of cement, probably with high values, high replacement, GBS cement, which could also be pulverized by fly ash or microsilica or silica fumes. Particular arrangements are to work out. Particular arrangements are worked out for curing solutions for such low heat generations, low heat generating cements to affect thermal curing methods, utilizing no direct contact with curing water but thermal curing methods. It should be made clear the foundation block is massive concrete and may not be misunderstood as mass concrete. Massive block is higher in status than a thick element. Says, you can say again, I read this is the important one. Particular arrangements are worked out for curing solutions for such low heat generating cements to affect thermal curing methods utilizing no direct contact with curing water but thermal curing methods. It should be made clear the foundation block is massive concrete and not mass concrete. Do not misunderstand. Massive block is RCC1, higher in status than thick element. Massive block requires special method for pouring concrete as well as post-concrete pour thermal curing, which means that water should not be used in direct contact with concrete, such as flooding, but evaporation volumes, you can say pouring of such mass black should be conducted by step formation during pouring without formation of cold joints. Evaporation volumes released by concrete should not be allowed to leave concrete but cure concrete by use of thermal energy. Not allowing evaporation and using this evaporation do curing is named thermal method. Now we talk of cracking gas furnaces. We talked something here. It's of course very significant. We talk basics of foundations of such structures. In fact, it's very significant consideration from each and every viewpoint we have to consider. We have to consider from each and every viewpoint. We talked of, you might have seen about pouring of that. Just for reference, I can show you if you wish a program for it. It's not exactly what I mean to say. This is sketches. I don't know whether I can get something out of that. I don't think I'll get that one. I want to show you the way of pouring was done because it's long back I showed to you. Maybe I don't know. It's known to you or not. So I think it should be somewhere there. It should be sectional tank shooting, I would say, RC column forms. Maybe I'm not here to show you all, only some facilities sketch mass block concrete sequence. I think it's that here. It's here. Yes, it is here. I can show you that one. It's not a bad idea, you know. It's not a bad idea, you know. It's shown here, you can see. Also this you can see, let us say this is a foundation here, and you know, in section it's like this, and because this each activity is done here, and 50 layers are to be laid in this case. 50 layers, here 1, here is 50, here is 22, here is 31. So you can say diagonally, if you see 1 goes to 50 here, and then 1 goes to 2, and then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. Then you can see acute angles being spread everywhere. And quantity is 9.6 cubic in each layer. So you can see there are 50 layers. So 9.6 into 50, then see, is 48. 48. 480 cubic meters. It should be 480, or say approximately 100 could be. We have to plan accordingly, and that is very important. Position of pumps, location, position of trucks here, all this is shown. And there was a purpose of conferring with how to do concreting of that. So this is that point where we can say we can then so I'll take it off now because the purpose is over. So we close it and we'll see how to move further. So I tried to show you sequence of concrete construction, concrete pouring for massive blockades of 480 cubic meters of concrete. It's 480 here, it can be whatever quantity. You have to plan accordingly, and this means for purpose of cracking gas received from the refinery as byproduct, for transmission to compressors for production of ethane as well as propane. Now, since these are all heavy structures vertically oriented in group of vessels and founded on common base. So खोल दो यार उसको, आएंगे ठीक है, इसको खोल दो letter this point. So what we say about this is very simple here. We have to understand this point. Other structures we are talking of, other structures, what are those? Included wash water structures, for example, wash water structure, auxiliary boilers within processing area, processing trains, also included various vessels such as spheres to contain gases as well as tanks for storage. Foundations for tanks are generally constructed of RCC ring beams. Other structures are generally provided with independent footings, stripped using grade beams. These are certain other structures as we have discussed here, which is, you can start. This wash water structures, which name itself says, the washing water or wash water structure it is, and then boilers, auxiliary boilers, not exactly boilers, supporting boilers, can say, within process trains. And we have shown you that process plant already. If you want to see again, it can be shown again. Not a big issue, but because we have seen, I can say facilities sketches, photo, career projects involved. Let me show you this one. Career projects involved, that's the important one. This is plant we discussed before also. This is plant which is having all these, and then cracking furnace, for example. This is a facility ethylene here, you can say, this overall plant. Starting from here at C, this administration area, this is warehousing area, this is a processing plant, the support of that. Likewise, it is, then you can see this is different type of areas, admin warehouse facilities, and this is process area, this electric substation. And we're talking of this all process area. This is wash water structures and boilers here, compressors here, and likewise, cracking furnaces are all here. And you can say this is compressor area and plant process area. The supporting areas is also here is seawater. You can say, I think some missing somewhere. They go further, your substation here, you'll find flare here, and you can say landscape along with this area, this customer station, Samlet building, and this is mosque something, and this is their building. You can say same way here, and you'll find racks here, pipe racks as usual, and this is a complete process here. You can say then seawater basin here, and likewise substation roads and all that. And these are energy tanks we discussed before. Firing, shooting range, that's different ones. So I try to say all are covered in here. So we know what we are talking of. In fact, that's the reason we are talking of. And we can say then, okay, that's fine. And we are talking of this here. So we cite included structures. They include a wash water structure is one. Auxiliary boil is also one. That is within processing train. Also, you can say included various vessels such as spheres to contain gases, as well as tanks for storage. Foundations for tanks are generally constructed of RCC ring beams. Other structures are generally provided with independent footings stripped using grade beams. Now, another structure is very important is seawater basin. These structures which we discuss, other structures are not very difficult to construct. These are not very complicated but ordinary footings. Ordinary footing in a way means isolated footings or beams connected together, or if you can say not more than that, I think, because it's all field area, granular field area. There is no clay strata, and if they have no clay strata, then treatment will be different. No. These are other structures. Calling means normal structures, means just like ordinary building structures. For example, we are saying that RCC ring beam, it's, it's just ordinary structure. You can say we have structures, other one now, for example, water retaining structures, and that is you can say water retaining structures, which is very different. And we're talking of that's retention. It's very important item. I discussed shown to you seawater basin. So what we talk of that is water retaining structure, and that is seawater basin for cooling water storage and circulation. It says for cooling water storage. Cooling water what? Cooling water is required for purpose of heated elements in various operation areas. Plant operation area requires cooling, and for the purpose we don't allow more temperature than specification requirement of that machine. So we have to cool it, and for cooling water storage circulation, both purposes. What says we have to provide a reservoir, an open reservoir. This reservoir must be RCC construction. It cannot be otherwise because of its depth and its requirement. It's RCC open reservoir. RCC open reservoir, which is meant to continuously collect water from sea through, say, two pipes. Say, it's example, 84 inches pipes, 7 feet in diameter. Store in this reservoir. You have to store water in this reservoir, that's seawater, that is be conveyed or transported from sea intake as shown there, and in this reservoir supplied to plant various strains, requirements. And after cooling, installed system, used water to be disposed of from various industrial locations, to this receiving basin. There's another one, receiving basin, and then further to outfall chamber. Should this water may not be reused for process unit system cooling. Its huge voluminous open structure. Huge means quite considerable volume. It is not small one. Its huge voluminous open structure constructed of RCC base slabs provided various contraction and construction joints. During its executive on-site construction. Peripheral retaining walls up to 12 meters high, not more than 9 meters length of panels, as well as covered pump house, unit area and baffles. Such structures must be watertight effectively from all locations of water storage portions, duly tested for water tightness conforming to BS 8007 criteria or applicable Euro code. Ensure Euro code water retaining structures reference. Since BS structure related codes have been stopped being referred to since year 2010. Concrete protection is applied for both below ground as well as above ground RCC surfaces. So this concrete protection against soil, you know very well, applies to both below ground as well as above ground RCC surfaces. Testing would be little cumbersome. For many days. And Factor to be used for computing evaporations losses was complicated since no pertinent standard data being available. Testing will be a little cumbersome for many days. And factor to be used for computing evaporations losses was complicated since no pertinent standard data being available. A parallel arrangement as a device has to be arranged to observe real evaporation loss. Real evaporation loss model, result of which would be applied to reservoir operational observations. Many days are involved from start of water, filling, autonomous healing of surfaces, and then forming stage-wise applicable water tightness test. Many days are involved from start of water, filling, autonomous healing of surfaces, and performing stage-wise applicable water tightness testing. It could amount to 2 to 3 weeks for testing performance. If results being satisfactory, removal of water from reservoirs, otherwise, after removal of water, making repairs of water leakage as recorded by an application of resin injections to epoxy repairs, followed by another water tightness testing for final observation of leakage or formal verification of produced water tightness. Concrete. We talked of this tank. Of course, this is just a format of EPC. AnnexSL, only information is allowed. I'm not giving you total work done for this. For this, you can say water tightness test. But we should consider that this is significant one, very significant one, because this structure is water retaining one, which means water tightness is top priority in this case and in every such case, because purpose of this reservoir is to retain water, and if water leak is allowed, that purpose is defeated. We have to keep purpose safe and working. Design should be that level, and its working, its, you can say, prosecution should also have that level of achievement, that water cannot be disposed of through itself without any meaning, because we have to consider every point in this. Water tightness test is very significant. I think I've discussed that before in depth. Water tightness test of this one. That's a part of method statement probably. Let me see if I can bring it back. It's not in sketch form. It should be in method form, I'm sure. Water tightness test. Let me see if I can do it. Water tightness, BS something over there. BS 457, I think it is BS, right? But I'm not interested in code at the moment. I'm interested in something else. And that is also method statement will take. Let me see if I can find something in method statement immediately. I'll come back in method statement, and that is building water power generation, water transmission reservoir. Water transmission reservoir. No, it's not that. Maybe confused. I think so. Station crossing building plans, building non-plans. what to say for this water tightness sump, water tightness. I think something is here. Let me see what's that. It's seawater basin water tightness. I got it. I can see what says that. In just little concentrate on this. This is method statement chapter 4 and 7, and this is, so you can see, this is test of seawater. Try to get, and I got it. It's, I want to just clarify something. In this case, we have seen the scope here is to transport seawater to seawater basin, seawater to seawater basin, and testing major volume basin water tightness. And purpose of this statement is to define complete procedures to be adopted for conveying seawater by pumping from shore to location of seawater basin on plant site. Since quantity of water required to conduct water tightness test, pertinent seawater basin has been constructed is very high, which is not convenient to be transported and filled the basin using water tankers efficiently and economically. So what it says something. So we say, I think it was just a method to convey water from sea. How we would do that, but problem is not that. Problem is something else. My intention was not to show to you how shall water be procured from sea, but here is point here. You can see this is what I wanted to show you. Seawater basin plant pumping. That is what is important from pumping. So let us say let's concentrate on this. It is day 1, 2. It is quantity pumped in. It is quantity cumulative. This is important in this case. It says first day we procure water, that is 1008 cubic meter in one day. So this is cumulative quantity, and 1001, let's say idealistically, theoretically, so it goes on accumulating also. So you can say 21st day it is 21,168 cubic meter. On 21st day, we cannot fill it directly. There's a limit to which you can fill. Because it requires its autogenous healing itself. It's a kind of requirement once water is filled. Accordingly, we complied with that. And then we can say what it says for testing purpose. There are so many specifications for one thing, and they should know mix up. Now some specifications say one part, some says another part. In fact, what you say practically speaking, when tank is full, it's in service. This means everything has been done. Everything has been done. You can say, if specifications say you have to show water tightness when it's complete in use, or you have to show water tightness where nothing has been done except concrete structure. Now it's up to those who are, what do they think? I'm not sure that specifications can provide this information. We have to question ourselves. It says tank completed with protective coatings. One point is that what it says, if you see from use point of view, from practical aspect point of view, not just theoretical, water shall be filled and it shall be used while in completed state. This means water concrete protection shall be provided, its further protection shall be provided, backfill shall be provided, and everything shall be done, and then it will be used. This means there are two ways. One is to do as practical aspect, that why we should not test in a condition of completeness, or other one is we have to use only structural concrete water tightness. If it is structural concrete water tightness, I understand that better than work water tightness. Actually, it should be tested, concrete should be water tightness rather than system. That's most important, because if concrete is water tight, there's no meaning that leakage would occur. That point is of topmost significance. We have to understand that. We have to understand that it's realistic, it's important, and we can say what we are saying is right. And this really is a significant part, that how do you use this? You are going to test the tank water tightness, or you are going to test concrete water tightness. As far as I understand, being an engineer, it is concrete that should be watertight, it is RCC that should be watertight. From realistic angle, from theoretical angle, and from safe angle, water tightness. So if water tightness does exist in structural concrete, of course then finished quantity as such certainly be watertight. So we can say tank completed with protective coatings as specified and sealant applied, be cleared and filled in normal maximum level to meet requirement. We say in clause 9 to BS 8007, testing of structure is up to 11.5 meter. It should take 14 days and then be retained for a stabilization period, stabilization, absorption, and autogenous healing. 7 days for maximum design crack width of 0.1 mm. So here, because we are considering crack width, and that crack width is of concrete, this means it's indirectly telling, it's directly tells that you have to test structural concrete tightness. Test period starts about now, so 7 days, and drop in level recorded by be made every 24 hours during 7 days period. Total permissible drop in level, allowing evaporation, etc., should not be more than 1/500. 1/500 of average water depth of full tank, which limits to 10 mm or another specified or calculated amount. Having test been successful, backfill shall be carried out. Foregoing explanation provides application of concrete protection coating prior to water tightness testing, but preferably coating should be applied post successful water tightness testing. Focus on project decision depends on all team members, including engineer and consultants. Now circuit phase testing, we'll see circuit phase testing. Same way, I'm just trying to stress on this item, though it's not required in X. Again, I'm minding just for purpose of information, for purpose of as much information be given to everyone as is required on site, because this is kind of work talk, it's kind of work training. I should not skip off this one. So we can say second phase testing. Tank shall be further filled. Tank shall be further filled up to 13-meter level, that is another 7 days should be allowed. Stabilization for another 7 days for absorption and autogenous healing. Test period another 7 days. Level drop according at interval of 24 hours. Evaporation. This technical point comes into picture now. Very technical point, evaporation. Now, since evaporation loss is required to be included for this test, as it is to be tested in open, exposed to sky, but there is no formula. There exists no formula applicable to such testing conditions. Loss of evaporation shall be monitored in, you can say, shall be monitored in resemblance only by keeping a water-filled tray on surface of water during test by noting original level when filled. During testing and recording test observations from tray would also be recorded for incorporating into main observation. The size of basin is much more than that of monitoring tray. Yet an idea about evaporation would assist in calculations. What can you say here at this point? Now, what it says basin filling and testing schedule. You can say first phase water pumping 14 days. Duration in days 14 days. First phase water pumping, duration in days 14. Pumping from sea, you can say, or whatever else, doesn't matter. If you don't take from sea, you have to bring water from elsewhere through tankers. So it doesn't matter how you do that. Site has to decide there's sea or no sea. That's also. Then retained water stabilization to allow absorption and autogenous healing, that is 7 days. Testing at 24 hours intervals and monitoring, that is 7 days. Loss should not be more than 1/500 of average full water depth or 10 mm or other specified value. But backfilling after, you can say, backfilling after successful testing 14 days, second phase water pumping 7 days, retained water stabilization and autogenous healing 7 days, and testing at 24 hours interval. Then water loss monitoring. Water loss monitoring. Loss should not be more than 1/500 of average full water depth or 10 mm or other specified value, but excluding evaporation. Now, code provides. What does code provide? Where to see that one? It says the code provides notwithstanding satisfactory completion of test, evidence of scope of seepage of liquid to outside faces of liquid retaining walls should be assessed against requirement of specifications. Necessary remedial treatment of concrete cracks or joints should, where practicable, be carried out from liquid phase. Remedial treatment of concrete cracks or joints should, where practicable, be carried out from liquid phase. When a remedial lining is applied, to inhibit leakage at a crack, it should have adequate flexibility and have no reaction with stored liquid. Should structure not satisfy 7 days test, then after completion of remedial work, it should be refilled and, if necessary, left for a further stabilization period followed by further test of 7 days. Duration should then be undertaken in accordance with this clause. Now, what is required is we need to acquire out, you can say, equipment for transmission and something else, so that's different case here. Our purpose was this, so I close this then, and now we come back to our original talk. You can say, what is that original talk here? Now, we talked of seawater basin testing for information purpose only. That was not part of annex, but because when we talk of something and it's something rare, it's something you can say seldomly available, then we have to concentrate on that also from different viewpoint, not from same viewpoint. And that's the reason I just included that chapter here also, that method statement here also, so that you should get as much information as possible. Because you are not a student now, you are a professional, and professional has no limits. Professional can go to whatever limits, whatever divergence is available. There is no limit, and we can jump onto, because ultimately we have to do work. That was reason behind that. Now, many other stationary as well as vibratory equipments are included for processing plants. Many other stationary as well as vibratory equipments are included for processing plants, for which foundations would be constructed. Foundations would be constructed accordingly, either as footings, bases, or combined footings. These horizontal and vertical vessels are erected on these bases, on these foundations, connected using anchor bolts and grouting done between sitting steel plates and top of concrete in that another space. For vibratory equipment, epoxy grouting is applied, while for stationary equipment, cement-based grouting is suitable. This is just principle we are talking of. Now, we go to sump chambers. What are sump chambers? I think you remember I explained you some chambers. Yes, if you forgot that, no issue. I'll find again, and water tightness sump chambers I'll show you, and I think sketch is more important than this. I hope so. I have here, but let me show you once. Let us see. Okay, I'll show you this method statement also for reference. That's this much. And this is here, you can say, here is this, and I just like to show you the sketch. It's also very important, the sketch, sump chambers. Sump chamber, yeah, I got it. Yes, I got it. So we rotate it. It's better if I rotate it. So here is some chamber. You can see that one. That gives some time now. About 5 minutes. I'll be back. We by that time this chamber and understand. I think I'm late. No problem. What to do? There's no other way. Late or no late, what to do? I have to go here and went here. Let us go and see and talk about this. I think they have taken care of some chamber which I showed in display. I'll put this off. Accept this collection chamber. I put this off, but I think I should put this off. Some chamber is there. Which one I should put off? No. No problem. Let it open and we will continue. Now this is plan of some chamber, and here is very simple structure. It is very simple structure. You can see just 14.2 meter by 9.2 meter. You can say dimension doesn't matter. And here is 1 meter projection for this foundation, and 8 meters is internal headroom. This inlet and outlet. Inlet, this outlet. And here, it's so simple. There's nothing as such. It's closed, of course. So we may say we're not talking of safety here. We're talking of structural testing. And here is statement of this. This is numbers of notations, and we have to check again same. An important point is that quantities are given. That doesn't matter. Not that much quantity as in seawater. Basin case, it's different quantities, very small quantities, of course. But method same. Sketch 9 is preferred. The structure to be tested should be complete of all RCC constructions in line according to specified and agreed procedures. Complete filling of tie rod holes with MBT master flow. You cannot leave them, otherwise what is involved. Shall be carried out in line according to manufacturer's instructions. Inlet pipes 60 mm, 6 mm, dia, or all separate dia for all ones, so it doesn't matter. External surface of structure shall be prepared and applied to specific prospective as we did before. And likewise, same procedure applies. This is about water testing. Watertight testing should be considered without carrying out backfilling and application of water reporting system for accurate assessment, as well as compliance with tanking technology. Entire surface of structure to be tested shall be sealed plastered, removing all loose piles, dust, dirt. Prepared internal surfaces shall be inspected by civil contractor, and following operations shall be involved to conduct water tightness tests in line according to BS 8007. That's applicable to liquid retaining structures. And you can say graduated stick shall be provided on the wall top to show water level to a mm count. Potable water shall be filled in with respect to some pit structures at a rate of 2 meters per 24 hours, for which test filling schedule shall apply. After water is filled into required level, it shall be allowed to stay for a period of 7 days for stabilization, absorption, and autogenous healing. If required, water shall be added to maintain maximum test level in case it is lost during this period. Test shall commence from 8th day and continue for 7 days for a designed crack width of 91 mm according to specification requirements. Observations regarding water level drops shall be recorded every 24 hours by swollen measurements on scale. Test record shall be documented on attached form. Structural leak test and judgment on test method accordingly during 7 days period. Total permissible loss in level shall not exceed 1 over 500 of average water depth in full tank or 10 mm. After test is successfully completed, water shall be pumped out either to another structure for testing should that be ready to receive it, or if not, to other construction areas for curing or some other purpose. In this structure is roofed by a CC, which doesn't pose any considerable chance for water loss by evaporation. Especially consider while assessing total loss in level, calculated absorbing loss due to evaporation plus loss due to leakage. Remedial works. In case of unsatisfactory performance of water tightness test and upon agreement with contractor engineer, injection grouting method may be adopted to seal back seepage routes. It must be marked based on inspection during leakage. Should instruction not satisfy 7 days test after completion of remedial work, it should be refilled and if necessary left for further stabilization period as conducted earlier for a further test of 7 days duration must then be undertaken in accordance with specific code. So we can say schedule here. First is filling potable water in some pit 1 meter deep 1 day. Tank filled at uniform rate, targeted in 2 meter 24 hours. And here's the other one. You can say next is filling potable water to another 2 meter depth to make 4 meters. In this case, we are not getting water from sea, we are getting water through tankers because it's very small quantity. Then third is filling potable water remaining depth, that is you can say by tankers, that is maximum supply level. Stabilization period 7 days, that's for absorption and outer sealing. Additional water to be filled. In testing period to record water loss by seepage and evaporation every 24 hours. This was 7. Monitoring regarding seepage loss and provisions of 1 or 500 of average depth of 100 of 10 mm. Pumping filled of water out of sites, so total period is 18 days. 18 days. This is test. After that, once test is over, you can say we can apply coating if required. And we shall produce a representative master seal 550 coating sample for approval by EPC contractor and client. Internal surfaces shall be coated according to approved sample. External surface shall be provided waterproof concrete protection membrane in line according to requirement. Civil contact inspection will be done. Structural backfilling shall be carried out externally to project specifications necessary. Field density test conducted to requirement. Application of floor steel specified. So this is what we say. I close this now, for this purpose is over, and we can close this also, its purpose is over. So this was some temp chambers, some chambers we have discussed it now. These covered chambers are used for collection of water from various catchment areas. That's what we are talking now about. Various catchment areas and constructed of RCC underground structures duly tested for water tightness using BS 8007 criteria, and refer the note given earlier for seawater basins. Now, concrete protection is applied for both below ground as well as above ground. Manhole catch basins, rainwater recesses are constructed using RCC materials. Manhole are meant for sewerage lines. Oily manhole for oil discharge catch basins for rainwater. Generally these units can say Manholes are meant for sewage lines, oily water manhole for oil discharge, catch basins for rainwater. Generally, these units be provided in large numbers for certain plant area, making it preferably to produce by precasting on site, for which all working details for proposed yard or factory, or you can say site, factory or yard, are required to be issued to site. Working details for each manhole to be precast. Working details for each manhole to be precast is coordinated and sketches prepared showing plan, all internal side elevations, locations of cutouts for informing and outgoing pipes, and shown real dimensions with details related to its cover and cover framing, along with location of embedded steps involved, if so required, depending on internal depth of manhole. Open ditches. Hey, if you want to see this will can be shown on of this so that it's be clear. The file is still open and I can, if you wish, I can box culvert, trenches, ductment, pipe culverts. I think we can go ahead and show this to you if it's my cat file. My purpose is the front method statement sketches. No. Pulpits. No. What's that? Method sketches. Manholes. It was somewhere else. Well, I think it's gone in form of. Pulpits. Let me go again and see. It should be somewhere here. I don't know. It's gone. Some chamber precast cover. See water basin, water pumping, television, culvert, pipe culverts. Water reservoir, manhole. I think I got it. Yes, it is. So let me open this file. I'll go at some important one. Let's see that one. Sorry, it's gone the other way around. So get back, go away. So is that you can see these are 4 elevations: north, south, east, west, north, east, south, and this is a plan. It clearly indicates, if you see this closely, it clearly indicates depth. It indicates openings. It is typically sketched. There are so many as such. This is, for example, if you're inside here, if you are inside this plan, where is north, where is south, where is east, where is west, if there is a wall only or there is some block-out, depending on pipe size, where steps in, cat steps in, all this is shown where it's covered here. This sketch is prepared for every unit. It may be sewerage manhole, catch basin, or some other, and that's where we can solve this problem about. So it's the one working to each manhole to be precast, coordinated sketches prepared showing plan. That's I tried to show you. Again, you can see that. You can see for a minute. It's just a model. Every unit requires some detailing, and even if there's a clash on site, then further resolution should be done. That's the only way to deal with this. Otherwise, we can't deal with this. That's basics of this. So we can say this is working details of each manhole, 3 precasts coordinated and sketches prepared showing plan, all internal side elevations, locations of cutout for incoming and outgoing pipes, and shown its dimensions with details related to its cover and cover framing, along with locations of embedded steps. Walls also required depending on internal depth of manhole. Now, I think we should close this because there's nothing left in here. We're talking open ditches now. Open ditches. Open ditches. Open ditches. What are open ditches? In fact, these are drains with gravity flow. Of course, these are not covered, having 3 sides, one is base and 2 sides vertical or inclined. No cover on them, because rainwater has to go into them from roads, from other surfaces, and directly from rain. These ditches can also be used for purpose to give way to fire water disposal during whatever fire break out on installation. That's another point of additional use. Ditches may also be used for demanded purpose of intended water line maintenance. Means can be used for demanded purpose of intended water line maintenance, discharge received from some single loop. At commencement, ditch section is considered shallow because we have to start from there. At commencement, ditch section is considered shallow, but as it reaches within various catchment areas, it takes water. Ditch section is gradually and considerably deepened, like resembling a big city drain. Now we are talking of something else. This is a very easy part. That swale, generally call it ditch drains. Now we are calling piping. Piping is, you can say, backbone of every plant. It's very complicated but very useful, and varying diameter of pipes are used for every service. And these pipes that carry service other than structural wall, piping means various classes of pipings. Can be ductile iron or fiber reinforced plastics. That can be GRP, ERP, GRE, carbon steel or ductile iron or fiber reinforced plastics family. GRP, ERP, GRE, etc. are included depending on requirement. And structural adequacy to sustain various impossible stresses. Stress analysis is carried out for various loops, giving location of various supports as well as anchoring requirement. Various types of supports are designed for varying diameter of pipes for ground or underground or above ground use. FRP pipe, fiber reinforced plastic pipes. FRP is fiber reinforced plastic pipes. RTRP. RTRP means reinforced thermosetting. Reinforced thermosetting resin pipe. Reinforced thermosetting means setting by heat energy. Thermosetting resin pipe. A composite material consisting of a thermosetting resin pipe, a composite material consisting of a thermosetting polymer. Thermosetting polymer. Thermosetting polymer, a type of polyester. Reinforced thermosetting resin pipe, a composite material consisting of a thermosetting polymer, a type of polyester reinforced with glass or other fibers that provide strength and stiffness to a composite material. It is polyester reinforced with glass. Polyester reinforced with glass or other fiber. Glass is fiber. Other fiber that provides strength and stiffness to composite materials. Different types of resins used for manufacturing, that is GRP, GRB, GRE pipes, are isophthalic resin. Isophthalic resin, that is vinyl ester resin. Here say GRP is isophthalic resin, GRB is vinyl ester resin, and GRE is epoxy resin, respectively. We have to remember P for isophthalic, we have to remember V for vinyl ester, and GRE for epoxy, E for epoxy, V for vinyl ester, P for isophthalic, respectively, that are selected according to required properties such as chemical resistance, temperature resistance, and other mechanical properties. We require what? Chemical resistance, temperature resistance, and other mechanical properties. To fulfill these requirements, we elect accordingly. Resins provide thermal and chemical properties. Resins provide thermal and chemical properties. Sorry. Cough. I can't speak a lot, I think. Resins provide thermal and chemical properties such as glass transition temperature, resistance. Other mechanical properties says resins provide thermal and chemical properties such as glass transition temperature, resistance to heat, chemical resistance, etc. required for finished product. Properties of GRP pipes can be varied by changing ratio of raw materials as well as winding angle. These pipes consist of 3 layers, adherent to each having different characteristics in relation to functional requirements. Particular information layer for reference only. Only for reference this is. Inner liner. Talking of inner liner, that is inner liner, that is VL, glass is called VL. That's glass, resin, CSN glass, that is, and resin. Inner liner, VL glass, resin, CSN glass, structural wall, roving glass, resin, and external inliner, VL glass, resin. Composition, inner liner, VL glass, resin, CSN glass, resin. Inner liner layer is chemical resistant because it's in touch with chemicals. So inner liner layer is chemical resistant due to remaining in direct contact with fluid. And therefore responsible to resist chemical corrosion as well as permeability. Internal surface is particularly smooth to reduce fluid head losses. Internal surface is particularly smooth to reduce fluid head losses and also opposes growth of minerals and algae. That's very important. This liner has two monolithic sublayers. Inner one is in contact with fluid, is reinforced with glass VL. Inner one, which is in contact with fluid, is reinforced with glass VL with resin content 90%, while outer one reinforced with CSN glass with resin content 74% by weight. Standard liner thickness is about 0.5 to 1.5 mm. Structural wall, roving glass, that's resin, glass reinforced layers guarantee mechanical resistance of whole pipe against stresses due to internal and external pressure, external loads as well as thermal loads. For GRB pipe, this layer is obtained by applying on previous partly cured inner liner continuous roving of glass, wetted with resin under controlled tension. For GRE pipes, the structural wall is wound directly on a wet liner. This layer can contain aggregate like silica sand if allowed by specifications, while thickness depends on design conditions. External liner, real glass resin, top coat or external liner is an outer layer of pipe consisting of pure resin. UV ultraviolet protectors may be added if so required to protect pipe from effect of solar exposure. In case of meeting severe exposure condition such as aggressive soil or very corrosive environment, this external liner can be reinforced with a surfing veil or added with filters or pigments. Fiberglass composites consist of glass fiber reinforcement thermosetting resins, and additives designed and processed for to meet specific functional performance criteria. I think it's already more than 3 minutes, 3 hours. So I think we should stop now for time being, because it's a very interesting topic, and that is epoxy pipes. I'll take care. Meanwhile, we have gone through quality system, and that is very important one as we discussed today. And that's why it's done. If we cannot get this, if we cannot apply our engineering or sciences to quality achievement, there remains no meaning of, you can say, quality at all. This has got no meaning. That's the only reason I'm trying to spend time on this. Really, it's very much interesting that we have to be careful about this, or else whole project of this talk goes waste. No need of that. So we have to be very careful what we are talking of, and how we talk of. That point must be carefully understood.